Hello everyone and welcome back. Today we are diving into one of the most critical topics in machine learning and data science interviews, overfitting versus underfitting. To put it in the simplest term possible, overfitting happens when a model becomes too specific, while underfitting occurs when a model stays too simple. Think of overfitting like a student who memorizes the exact questions from a textbook but fails miserably when a slightly different question appears on the actual exam. In machine learning, an overfitted model performs exceptionally well on the training data but fails to generalize to new unseen data. To prevent this from happening, expert developers use several proven techniques. First, they implement cross validation to ensure the model evaluates well across different subsets of data. Second, they apply regularization methods like L1 and L2, which penalize over complex models. Additionally, you can use pruning for decision trees to cut off unnecessary branches, implement dropout in neural networks to randomly deactivate the neurons during training, or simply collect more training data to give the model a broader perspective. On the other flip of the coin, we have underfitting, which is like a student who didn't study enough and doesn't even understand the basic concepts. An underfitted model cannot capture the underlying trend of the data, performing poorly on both training and testing datasets. If you want to prevent underfitting, the solutions are completely opposite. You need to increase your model complexity, add more relevant features, reduce your regularization penalties, or simply allow the model to train longer. Striking the perfect balance between these two is the ultimate key to building a robust machine learning system. Now that we have mastered the core theory of model behavior, let's transition into the practical side with a classic entry level Python interview question. The challenge is straightforward. The challenge is straightforward. Write a program to print the first 10 natural numbers on the screen. To solve this, we can write an elegant two-line Python script for using a for loop and the built-in range function. The code starts with for I in range 111, 1, 11, followed by an indented print I on the next line. Let's break down exactly how this works behind the scenes so you can explain it flawlessly to an interviewer. The function range 1, 11 is the core engine here. It generates a sequence of numbers starting from 1 up to but not including the stop value of 11, meaning it precisely gives us numbers 1 through 10. Then the for loop combined with the print function takes over, iterating through that sequence one by one and printing each number on a new line. When you execute this code, the sequential output displayed on your screen will be exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This fundamental logic demonstrates how loops handle repetitive tasks efficiently in Python, which is a building block for writing the complex data pre-processing scripts we discussed in our machine learning segment earlier. Practice writing this out, understand the exclusive nature of the upper bound in the range function, and you are good to go. Thank you for watching and happy coding.